Okay, let's look at question 3 now. So question 3 is number patterns. So 3.1, consider linear sequence 5, 8, 11, b, 17. Write down the value of b. So that's pretty straightforward. Let's see what the pattern is. So you can see from 5 to 8, I added 3. Same thing from 8 to 11. So that means to get to b, I'll have to add 3. Okay, so 11 plus 3 is 14. Okay, so that's the value of b. Let's say b equals to 14. Okay, 3.1.2. Determine the nth term of the sequence. Okay, so remember for linear sequences, we have Tn is equal to, and then the coefficient of n will be whatever the difference is. So in this case, it's going to be 3n. Okay, and now you just test it out. Okay, so let's start with 3 times 1 is 1. So then to get to 5, we have to add 2. Okay, so let's see if this works. Let's see for the next one. 3 times 2 is 6, and then plus 2 is 8. 3 times 3 is 9, plus 2 is 11. So that means our formula is working. So this answer is correct. Okay, you should always test your answers to make sure that they are correct. Okay, 3.1.3. Calculate the value of the 15th term. So now that we confirm that our formula is right, we can just substitute in 15. So now in place of n, we're just going to input 15. Okay, so T15 is equal to 47. Okay, because that's 45 plus 2 is 47. Okay, 3.1.4 now. So this answer is correct as well. Which term in the sequence is equal to 83? So now if you look at this formula we have, essentially at any point in time we have two unknowns. So you have the value of the term and also which term it is. Okay, so in 3.1.3 we were given the n value, and our goal is to solve for the Tn value, right? T15, that's what we're trying to get to. Now in this case it's inverted. We're given what the answer is. So let's start here with this thing, 3n plus 2. We're given what Tn was equal to. It was equal to 83. And our goal is to solve for n because it says which term. Okay, so then we can just bring that minus 2 to that side. So 83 minus 2 is 81, and then 81 divided by 3 is 27. Okay, and then that answer is correct as well. Okay, let's move on to 3.2.1. Okay, so here we're given a pyramid looking thing with numbers, and it says consider number pattern below created by using the numbers of the sequence 2, 6, 10, 14, 18. So 2, 6, 10, 14, 18, and so on. Okay, and you can see that they added 4 to each previous term to get the next one. Okay, let's see if that's going to help us to solve the answer. Calculate the sum of the rows of the numbers in the 8th row. Okay, so how are we going to do that there? Let's start by seeing if there's some pattern to the sums of each row. Okay, so I'm just gonna do this like this, and then we can see if there's a sum, a pattern. Okay, so the sum of the first row is just 2, right? There's only one number. For the next one, 6 plus 10, 16. And then if we add all of these together, let's see, 14 plus 18 plus 22 gives us 54. and then 26 plus 30 plus 34 plus 38 gives us 128. Okay, now here is something that you can notice from here. Okay, so if we look at the first, let's call this row 1. So row 1, 2, 3, 4. Okay, if we look at this here, right, if I look at row 1, I took this n number, right, so whichever row it was, I multiplied it by 2 and I cubed it. Okay, so if I take 2 times 1, if I take 1 cubed, it's 1, right, and then 2 times 1 is just 2. If I look at the next one in the line, I have 16. Okay, so 2 cubed, because 2 is n, right, it's the second row, 2 cubed is 8, and if I times that by 2, I get 16 as well. So here I had 2 times 1 cubed. Now here on this one here, let's see what's 3 cubed. 3 cubed is 27. Okay, and then 27 times 2 is 54, so it's 2 times 3 cubed. Okay, here as well, 4 cubed is 64, and then times 2 is 128, so it's the same as saying 2 times 4 cubed. Okay, now what do you notice? That these numbers here are the same as the row number. Okay, so we essentially got a pattern where we have 2n cubed. Okay, where n is the row number. Okay, so you can show that there now. You could say row 1, the sum, let's say sum of row 1 equals to 2, sum of row 2 equals to 16, and so forth. And then you could show the pattern is that, right? And now all you have to do, because they asked for the 8th row, is to just do 2 times 8 cubed, which gives us 1024. Okay, cool. Okay, determine the mean of the numbers in the 20th row. Okay, so let's try and see if we can come up with something similar for this one here. Let's see if we can find a pattern for this one as well. Well, there isn't a pattern to find, because let's think about this, right? What is mean? Mean is the average, right? So it's essentially you take in all of the values, adding them together, right? This is mean. So you're taking all of the values, adding them together and dividing it by the number of values in that row, right? So, okay, let's keep that there so I can explain something. If you look at this here now, to get the mean, we need the sum of the row and also the number of numbers in that row. So we know how to get this here, right? That's what we did in 3.2.1. We found this equation. Okay, so we'll be able to find the sum. What about the number of numbers in each row? Well, if you look at it, it just goes up by the row number. So row 1 has 1 number, row 2 has 2, 3 has 3, 4 has 4, and so on. Okay, so let's look at this now. 3.2.2. So mean is equal to the sum over the number of numbers. Okay, So the sum of row 20, because that's what they're looking for, is just going to be our equation here that we found, but instead of n we'll have 20. So that, and number of numbers, like I said before, is just 20 because it goes up by each row number. Okay, now we can plug that into a calculator and we got 800 as the answer.